So by the end of this episode, we're going to take the most complicated part of all of neurology, all of neuroanatomy, and we're going to make it so simple and so easy to remember that you'll be localizing lesions within 2 millimeters of the entire nervous system. Absolutely phenomenal. My name's Prashant. I'm a neurologist and I teach neurology registrars and residents every single day. And today we're going to be going over the brainstem because this is the spiral neuroanatomy course. Now the brainstem is so complicated, but by the end of this episode, using the rules of 4, I'm going to get you to understand it. Super simple and it's practical. You can actually use it at the bedside. So let's get started. Now, if you remember back to the very first episode, when we localize lesions, we use the lines of latitude and longitude. The first question that we need to always ask is how high is the lesion? And then we want to know how deep is the lesion. And so that rule applies to the actual brainstem itself. And so let's start off by understanding the neuroanatomy of the brainstem by understanding the rules of 4. The rules of 4 was actually created by an Australian neurologist, so represent. But we're going to go over it today, and it's going to make it really simple for you to understand the brainstem. So what is the first rule of the rule of 4s? Well, the first rule of the rule of 4s is that you don't talk about the rule of 4s. The fact that everyone's here means people are talking about the rules of 4. Jokes aside, if you actually recognize that joke. So there's 4 rules to the rules of 4. Rule number 1, there are 4 cranial nerves above the pons, and that means the midbrain and above. There are 4 cranial nerves in the pons, and there are 4 cranial nerves in the medulla. Now, what is the second rule? The second rule are midline structures, so M. There are 4 major structures in the midline that begin with the letter M. These are the motor pathways, the medial lemniscus, the medial longitudinal fasciculus, and the motor cranial nerve nuclei. Okay, what's rule number 3? So the third rule is the letter S. There are 4 side structures that begin with the letter S. What are the side structures? 1, the spinocerebellar tracts. 2, the spinothalamic tracts. 3, the sensory trigeminal nerve nuclei. And 4, the sympathetic pathway tracts. And finally, what's rule number 4 is the midline motor nerves. Nerves whose numbers divide evenly into 12. So that's 3, 4, 6, and 12. Live in the midline. And that rule relates to rule number 2, where we said the motor cranial nerve nuclei live in the midline. Okay, well, now that you've got the rules of 4, I'll see you next week. No, just kidding. Let's go over this in good detail so that you can understand it. As always, excuse my horrendous drawings, okay? So, what are the 3 levels of the brainstem? Well, we've got the first level. This is your midbrain. The second level, this is your pons. And the third level, this is your medulla. Okay, fantastic. So now that we've got the 3 parts of the brainstem, let's move to rule number 1. So rule number 1, if you remember, are the cranial nerves. And we remember that by saying there are 4 cranial nerves that live above the pons. Now, if we remember back to the last episode where we went over the cranial nerves, cranial nerve number 1 and cranial nerve number 2 don't go through the brainstem. They go off above the brainstem. And that's why that wording is in that very particular manner. So when we say it's above the pons, really the only 2 cranial nerves that live in the midbrain above the pons are cranial nerve number 3 and cranial nerve number 4. Okay, now what lives in the pons? The 4 cranial nerves live in the pons. And so we're just going to count down, and that's why the cranial nerves are numbered in that way. We're just counting down the brainstem. So 1 and 2 is above the midbrain, 3 and 4 are in the midbrain, and then we have 5, 6, we have 7, and we have 8. And then we have 4 cranial nerves in the medulla. And so if you remember, that's just going to be the next 4. So that's going to be 9, that's going to be 10, that's going to be 11, and that's going to be 12. And if you remember from the last episode, we said these were the bulbar nerves because they're all coming out of the medulla. So that's it. First rule of the brainstem, the rule of 4s, is this. This is it. Now, let's move to the next level. Now, usually what I do at this stage is I actually skip to rule 4. In a way, if we want to think about it, we can shuffle the rules around a little bit. And that is, I take these cranial nuclei and I put them into the actual brainstem themselves, where they live. So if I was to take a little bit of a shade, so if we were to color in the sides, to the middle. This is what the middle of the brainstem would be. I'm actually just going to put a nice dotted line down the middle. I'm going to say this is left, and we're going to say this is right. So that's our midline, and that's our side. The next thing I do in this stage is I actually put the cranial nuclei into the brainstem itself. So if you remember in the rules of 4, the last rule in the rule of 4 was that the nerves whose numbers divide evenly into 12 are in the midline. So 1 and 2 doesn't count because that's not in the brainstem. But we can take 3. Does that divide evenly into 12? It absolutely does. So I'm going to put 3 in the midline. And what about 4? Well, 4 absolutely does as well. So 4 is going to go into the midline there as well. So those are the cranial nuclei that live in the midline, in the midbrain. Well, that's it. Let's move down to the pons. Does 5 divide evenly? Nope. Does 6 divide evenly? Yes, it does. And it's a motor nuclei. So we can put 6. Why don't we put 6 over on this side? 6 in the midline. What about 7? 7 doesn't. What about 8? 8 doesn't. Okay, so that's all the nuclei that live in the midline in the pons. And let's look at the medulla. Does 9? Nope. Does 10? Nope. Does 11? Nope. Does 12? Yes, 12 does. So 12 lives in the midline. So these are the nuclei that live in the midline, and the other ones live on the side. Well, for now, I'm going to leave that alone. Okay, and we're going to move to the second rule of 4, which are the midline structures. So this is rule number 2. It begins with M, and we've got 4 major structures that begin with M that live in the midline. Motor pathways, medial lemniscus, medial longitudinal fasciculus, and the motor cranial nerve nuclei. Well, we've already done the motor cranial nerve nuclei, so let's do the other ones. And the first one we're going to do is the motor pathway. So if you remember all the way back to when we started all those episodes before, we talked about the motor pathways. They start off with the primary motor cortex, they make their way down the corona radiata, they go through the internal capsule, and they make their way to the brainstem. So in the brainstem, where do they run? They run in the medial aspect. These are your corticospinal tracts. We're calling them the motor pathways, beginning with M, so they run in the midline. These pathways come down through the midline of the brainstem. Where do they decussate? They decussate at the lower aspect of the medulla, and they continue to go down to the spinal cord. Where do they synapse? The anterior horn cells. And it's all the way back, I can't remember what, episode 2 or something like that. But that's our first structure. So first structure going in to the midline were the motor cranial nerve nuclei. Second structure are the motor pathways or the corticospinal tracts. Okay, next we have the medial lemniscus. What is the medial lemniscus? I have never heard of this before. Well, you have actually. This is the name for the dorsal column in the brainstem. So the dorsal column are your sensory pathways. You've got your dorsal column, and we've also got our spinothalamic tracts. The dorsal column makes its way into the spinal cord, and it goes up the dorsal aspect of the spinal cord, and it gets to the lower aspect of the medulla. So it makes its way up the medulla, and it synapses here. This is where it synapses in the lower aspect of the medulla. It decussates around to the opposite side, and it goes up the medial aspect all the way up to the thalamus. So we'll label this as motor pathways, and this over here is the medial lemniscus. So it gets a new name because there is a synapse there that occurs. So if you remember, it comes in, it doesn't synapse at the spinal cord. It goes up this ipsilateral same side, and it decussates in the medulla. And when it decussates, it's through a synaptic process. New order of nerves come out, crosses over to the other side, makes its way up the medial aspect to the thalamus, and that's where it meets the spinothalamic tracts, and it then makes its way up to the primary sensory cortex. It's all coming together. This entire series is coming together beautifully. So that's the medial lemniscus starting with M there, and the motor starting with M there. So what's the third pathway? This is the medial longitudinal fasciculus. It's also called the MLF. And so what the MLF is, it's a link between the sixth nerve. It crosses over to the other side, and it goes up to the third nerve. So it's the connection between the sixth nerve and the third nerve. It crosses almost immediately and then makes its way up the medial aspect of the brainstem to the midbrain. Why does it exist? We will do that in the next lecture, or in the next episode. We'll go over the medial longitudinal fasciculus and the concept of an intranuclear ophthalmoplegia. But for the sake of simplicity for this episode, what does the sixth nerve does? It abducts the eye, so it lets the right eye abduct and look laterally, lateral rectus. And what does the third nerve do? It does everything else. But if I want to look right, okay, then I need to coordinate my sixth nerve on this side doing lateral rectus, and I have to coordinate my third nerve on this side doing medial rectus. And so to actually get the two to coordinate, we need something connecting the two, and that is the medial longitudinal fasciculus. So this that we've drawn out are all the pathways of the medial aspect of the brainstem. This is the medial aspect of the brainstem. Okay, so what I want to do now is just quickly recap. So cranial nuclei in the midline divide into 12. 3 and 4, then 6, and then 12. Then we have the motor pathways coming down, decussating in the medulla. We have the medial lemniscus, that is the proprioceptive vibration pathways of the dorsal column, making their way up, decussating in the medulla again, and then going to the opposite side and going up to the thalamus. And then we also have the medial longitudinal fasciculus, which connects the sixth nerve and the third nerve together so that you can actually coordinate your eyes looking left and right. Fantastic. Let's move to the next rule, which are the side structures, the S. So there are 4 lateral structures in the side. Before we do that, let's put in the other nuclei. So these are also the side structures as well. So there's nothing in the midbrain that would be on the side because 3 and 4 are taken, but everything else also goes into the side. And the first one we're going to talk about is the 5th nucleus, the 5th cranial nerve, the trigeminal nerve. And if you remember correctly, that is one of our side structures, sensory trigeminal nerve nuclei. The reason for that is the trigeminal nerve nuclei is actually a massive nuclei. It's huge. So it starts in the pons, but it stretches all the way down into the medulla, and it even has a little component that goes into the spine as well. So when we draw this, we're not going to draw just, V1 like that. It actually goes all the way down into the medulla, a little bit into the spine as well, and then it comes back up again. So this is the 5th sensory nerve nuclei. I'm also going to throw in here 7. So we'll put 7 over here, and we'll put 8 over here as well. Fantastic. And at the bottom here in the medulla, we have 9. We have 10, and then we have 11. So those are our nuclei that live on the side. So what do we have remaining of the 4 side structures? We've already done the sensory trigeminal nuclei, which goes all the way down from the pons to the medulla. The other structures are the spinocerebellar tracts, the spinothalamic tracts, and the sympathetic pathways. So let's start with the spinothalamic, only because we have talked about the medial lemniscus. Let's talk about the spinothalamic. So the spinothalamic is pain and temperature from the spine, and it comes in through the peripheral nerve, and it decussates almost immediately 2 to 3 levels, and then it makes its way up. And remember, we've done this in a previous episode, and that's the thalamus episode that we went over and we talked about this. And if you want a refresher, you can go to that one. But we have the actual spinothalamic tracts coming in, decussating pretty quickly, and then making their way up the spinal cord and onto the lateral aspect of the brainstem. So why don't we do it on this side? So it comes up on the lateral aspect of the brainstem, keeps going, and where does it end? In the thalamus. So the medial lemniscus and the spinothalamic tracts, and let's write that in here, spinothalamic. The medial lemniscus and the spinothalamic tracts are in different locations in the brainstem itself. So that's helpful for localization, but they're in different locations. So the spinothalamic tract is on the side. It goes up on the side. And the only place these two come together is the thalamus. So remember one of those rules we talked about in the thalamus episode? If the patient has spinothalamic and proprioception and vibration loss all on the same side, then the lesion is highly likely to be in the thalamus or higher. Could be in the brainstem, but you'd have to knock off the entire aspect, lateral and medial of the brainstem. That would be a very, very, very severe lesion, and you'd have a lot more signs than just pure sensory loss. Okay, what's the next structure on the side? And the next structure is the spinocerebellar tracts. So the spinocerebellar tracts, they go from the spine to the cerebellum. So always remember that spinocerebellum, spinothalamic tells you spine to cerebellum, spine to thalamus. Corticospinal tells you from the cortex to the spine. So it gives you a clue. So let's draw that in green here. And we're going to say this is coming up on the side. And these are ascending fibers as well. These are going up. Let's write this here. Spinocerebellar. So we've got spinocerebellar tracts. And so this is to do with how we control movement, coordination, etc. We are going to do the cerebellum coming up in another episode. And so when you start seeing cerebellar signs, we know that these tracts could be involved. So pass pointing, dystiokinesis, nystagmus, they can all be involved when these tracts are involved. So here's a very important rule to remember. The cerebellar tracts decussate twice. So they go across once into the cerebellum and across again when they come out of the cerebellum. And so two negatives kind of make a positive, and in the process, a lesion of a spinocerebellar tract on the right-hand side gives you right-sided cerebellar signs. It's ipsilateral. It's the same side. Everything else we talk about is the opposite side before the decussation, but with spinocerebellar tracts, it's the same side. So remember that. The last one to know about are the sympathetic tracts, or the sympathetic fibers, or the sympathetic pathway. And so what this is are pathways coming, let's do it on this side, down, okay? And so these are your sympathetic fibers. And so what they are doing is they're innervating. So these sympathetic fibers are the ones that innervate the sense sweat on your face, your eyelid being up, and your pupil. So think about your sympathetic and parasympathetic fibers as your autonomic system. Now, sympathetic is the fight and flight response. You see a tiger in the bush, you get really stressed, you start sweating, your pupils dilate to get as much light in as possible, and your eyelid elevates as well to kind of open up your eyes so you can see everything. Now, if you get a lesion in the sympathetic pathway on those tracts, you get a Horner syndrome. So what's a Horner syndrome? A Horner syndrome is the opposite. You lose that sweating response because the Horner syndrome is the parasympathetic fibers, which is to do with being relaxed and easygoing. They are overworking, they're overriding, and the sympathetic is no longer working. So you get a lack of sweating on your face, you get a ptosis with a droopy eyelid, and you also get a constricted pupil. So the very opposite of that fight and flight response. Ptosis, meiosis, and anhidrosis. And we'll go over those pathways outside of the brainstem in another episode altogether. But for this episode, if you get a lesion that gives you a Horner syndrome in the brainstem, it's going to be on the lateral aspect of the brainstem. So just to recap, what is on your side structures? We've got our cranial nuclei that don't divide into 12, and very specifically the trigeminal nuclei that goes all the way from the pons down to the midbrain. We also have our spinocerebellar tracts, the lesion of which would give us dysmetria, dystiokinesis, nystagmus. We have our spinothalamic tracts, a lesion of which would give us pain and temperature loss. And then finally, we have the sympathetic pathways, a lesion of which would give us a Horner's syndrome. So here, we have drawn the entire brainstem, that everything you need to know really up to the level of I would say, a senior neurology resident. You know, as a junior neurology resident or registrar, I was running around with only this amount of knowledge. I know a little bit more now, but back then, this is all you needed to be at the bedside, actually localizing lesions and making a diagnosis. So how do we actually use this? And we go back to our lesions of latitude and longitude. So I'm going to go with a black pen here. And so the first thing we need to figure out when we've got someone with a brainstem lesion is what is the height of the lesion? Okay, so how do we figure out the height of the lesion? We use the cranial nerve nuclei for us to figure out the height. So if we go back to our last episode on cranial nerves, if someone has a deficit with their eyes, then we can start thinking, is it 3, 4, and 6? And then we can do an examination, we can localize it a little bit more, and we can say, actually, this person has a 3rd nerve palsy or a 4th nerve palsy. And what does that do? That skyrockets you all the way up to the midbrain. And let's just say you're doing your exam and you say, hey, actually, they've got a 6th nerve palsy. That's all they've got. Well, that skyrockets you up to the pons. And let's just say they have facial problems. They've got a facial nerve palsy, or they've got something to do with sensory loss. Well, that's to do with the 5th, and that's to do with the 7th. And so there's a high likelihood Now this is going to be in the pons. Now, of course, the fifth nerve goes all the way down, so we need a few more clues there. And so the final aspect is if they've got dysfunction with their swallowing, their chewing, their eating, their tongue, or their speech. So dysarthria, dysphagia, and you automatically think, could these to do with the bulbar nerves? And this is in the medulla. So based on what they complain about, we can automatically figure out some level of the height, and then after the examination we can narrow down the height even more by using our examination to pinpoint the exact cranial nerve. So now that we've actually figured out what the height of the lesion is, so let's say they're coming with issues with their vision, they've got double vision, you've done an examination, you say this is a third nerve palsy, we've taken it all the way up to the top. Now the next question is, how deep is the lesion? And so is it in a lateral structure or the side of the brainstem, or is it in a medial structure in the midline of the brainstem? And what do we use? We use those tracts that are going up and down, and we use our knowledge of what's on the side and what's on the midline. So if they say they've got a third nerve palsy, well, I can pretty much quickly narrow it down to the midline because of the fact that these live in the midline. But we want a little bit more to reinforce and understand what we're dealing with. And so if the patient has weakness with upper motor neuron lesions, then we know the motor tracts are involved. If they've got proprioception and vibration loss, we know the medial lemniscus is involved. And if they have an intranuclear ophthalmoplegia, we know the lesion is anywhere in between these two regions of the pons and the midbrain. So we can use these side structures and these midline structures to help us figure out the depth even further. Now, here's a very important golden rule. If you have multiple cranial nerve palsies, you have a third, you have a fourth, you have a sixth, and you've got no long tract signs or no tracts that are involved, so no motor tracts, spinothalamic tracts, no proprioceptions, no sympathetic, nothing, they're just cranial nerve nuclei, the lesion is outside of the brainstem. Okay, very important, because look how many tracts are running in what is essentially a tiny 50-cent piece. And so if you were to have multiple cranial nerve, you would expect to see some of these other tracts involved. So if you don't, then the lesion is outside of the brainstem. So what does that mean? The lesion is either in the multiple cranial nerves, it's in the subarachnoid space and the meninges as the cranial nerves are making their way out and they're getting entrapped there, or it's further out in the periphery. So that's an important rule to understand. Okay, so next week we're going to go over intranuclear ophthalmoplegias and the pathways of the medial longitudinal fasciculus, so we can explain this final aspect here as well. The episode after the intranuclear ophthalmoplegia, we're going to do an episode that's just a bunch of questions and cases, and we're going to run through this exact structure to help us localize where the lesion is, just based on these questions. So we're just going to try to do some practice to understand this. So it's kind of a three-parter if you want to think about it. This episode, the I Know episode, and then we're going to do a whole bunch of questions to understand this a little bit more. If you have learned something today, do not forget to check out the website, www.basic-neurology.com. The link is in the description below, and check out our courses. I've been teaching neurology for over a decade now, and I've known people who have gone from absolutely knowing nothing to being really good at neurology and even pursuing a career in neurology just because they've loved it so much. I presume you know nothing, and we start with the very basics, but we fill it all the way up to the point that you are brimming with absolute neurology knowledge and a master. So go check out my course. There's something for everyone, so that you can learn neurology properly for the first time and fill in all those gaps. Don't forget to subscribe. I'll see you next week.